So this tool is our logger's tape. Foresters use logger's tapes for multiple reasons. The most common reason is to take the diameter of a tree. The reason a diameter is important is because it allows us to estimate the volume of wood so that we can determine how much each individual tree is worth and how much money's worth of timber there would be on an individual plot. So on one side, if you notice on a logger's tape, on one side the increments are large, between 0 and 1, and you flip over to the other side and it's actually inches. So the reason for that is if you think about it as you learned in math, pi is 3.14, which allows you to convert from circumference down back to diameter. So a diameter is the distance straight through something and not around. So this tape automatically calculates that for you. It does have one little safety concern. That's going to be the tack that you actually use to stick into the tree. But all you would simply do is just wrap it around the tree. And you come back and you look, and if you notice, you have a 6 and a 7. Okay, so this would be the actual diameter of the tree. This 0 would be the starting point. So the way that we do this in the forest industry, instead of being to the exact 10th, for most practical applications, all you're going to do there is go to whichever number it's closest to. So for this example here, it would be a 6. So once again, that is a logger's tape. The one thing that there are two things you have to be careful with, like I said, was the tack that sticks there. That is very sharp because it's used to stick into a tree. And then it's also spring loaded, which means it goes out and in on its own. It actually just goes in on its own. So you have to make sure that as you're using it, that you regulate the speed of it by lowering and raising your finger or whatever to put pressure on the spool from reeling back in. So this tool is called a clinometer. A clinometer is used to measure the heights of a tree. We'll show you another tool in just a little while that looks very similar to it called a compass. But the way you can tell a clinometer from a compass is looking actually at the dial and looking at the numbers and the lack of letters on a clinometer, whereas on a compass, if you look at it, you'll see that it has northeast, southeast, northwest, southwest. We have two different types of clinometers. We'll do our best to make sure that you always have the right one, but the way that you can tell it's the right one is because if you notice where it says right, it's 1 to 66, so a ratio of 1 to 66. So in order to use a clinometer, you would actually use the logger's tape to back off 66 foot from the tree, and you're going to take two measurements. You're going to get a measurement at the base of the tree, and you're going to get a measurement at the top of the tree. And then what it does is it has a built-in system that uses angles to estimate height. These things are very accurate. If you notice, and this is just for future reference, if you notice there is a dial on one side and the other side is solid. So you cannot see straight through it. So you actually have to be able to use both eyes and be able to use your peripheral vision to be able to use this idea. So I don't think the hand compass is another tool that we'll commonly use in this classroom, and it is simply used for direction. So everywhere you look, there is a different letter and number combination for this. And just remember in the class, the way that we're going to record this is north or south first, our number, and then east or west. And we'll explain, and it's similar to the clinometer in that you cannot see all the way through it, so you actually have to look over the top of it. But like we said, a clinometer is used for tree height, and a compass, which is what we have here, is actually used to measure bearings or direction. So this next piece of equipment is an ancient artifact known as the Biltmore stick. These aren't as commonly used now, but we're going to go over it anyway. So a Biltmore stick, if you'll look, there's two different sides to it. You see one where it says diameter of tree in inches, and then if you flip over, it says diameter of log at the small end. We're worried about the diameter of the tree in inches, so always make sure that you're using this. So not only is it used to measure diameter, but you can also flip it over and you see where it measures the number of logs. So as we've probably already talked about, but I will remind you, a log is a 16-foot increment of a tree. So therefore, if I say a tree is 2 logs up to the maximal diameter, that means it's 32 foot. Likewise, as I go on, you just keep adding 16 foot, 16 foot, 16 foot until you get the actual height of the tree. This also allows us, it's kind of like the clinometer and the logger's tape, it allows us to get an estimate of the volume of standing timber, which then allows us to give an estimate of the price so that foresters are able to purchase wood, purchase trees and tracts of land from landowners and give them an accurate quote. This is a wedge prism. If you look at it, it comes in a leather pouch for a reason. This is a very easy to break piece of glass. Wedge prism is used to determine basal area of a property. And the way I define basal area is the degree of stocking. So basically, when you go out into different pieces of land, not all piece of land has the same amount of trees per square foot. So trees that are planted artificially, that are planted in rows, are naturally going to have a higher degree of stocking or higher basal area than trees that are natural. So this is actually another part. So we've talked about loggers' tapes, inclinometers, and Biltmore sticks being able to be used to determine the height and diameter of trees. But this right here allows us to estimate the degree of stocking so that we don't have to go through the woods and measure every single tree. So this speeds up the process. There's a nice formula that we'll learn on how to utilize this piece and be able to cruise timber in a more efficient manner. This is what we refer to as a dibble bar or a tree planting bar. So its name kind of speaks for itself. It comes with a blade that is actually, so you're going to bury this all the way down. So it's basically an 8-inch blade that you use to pierce the soil in order to plant pine tree seedlings. So the way this thing operates is you shove it straight down in the ground, push it back and forth to make a hole. You stick your pine seedling in, you come back behind and close at the base of it, push forward to close at the top, so that there's no air pockets in the tree, in the soil that would actually kill the tree. So tree planting bar or a dibble bar. Up next we have the increment borer. Bonus points for anybody that can spell that one correctly. So if you notice, it has a T-shaped handle. So when you actually open this thing out of the package like normal, this piece is actually put down into here and it goes together in a nice little pack. But we went ahead and assembled it for you. So an increment borer, if you look on one end, it has the T handle. On the other end, it has a threaded area. So basically, similar to a drill bit. So what you do is you actually take this thing, stick it up to the tree and push it in, and it drills into the tree. And when actually, as it goes into the tree, once it gets to the center of the tree, it has another little piece that you slide in, you twist it one more time, pull that piece out from here, has a little blade, and it gives you a core sample of the tree. So it's basically a piece of the center of the tree about the size of a pencil. When you pull that out, when you get that core sample, some of the things that you'll be able to notice, like on a tree, if you notice, and we're going to talk more about this in dendrology, but you notice how it has all of these annual rings. So this allows us to tell a bunch of different things, whether it's the age of the tree, or you can actually see growth patterns. If you notice on this ring right here, you notice how wide and fat it is, and then you come on further down here and you get to noticing how some of them aren't quite as big. So that tells us a lot about the individual tree itself, but also about environmental conditions and stuff too. So this is a measuring wheel. I'm going to put it up so that you can see it like this. And basically what this is as it rolls, as this wheel is moved, it has a little clicker that ticks right here. And every click is a foot. So this allows us to measure distance in a more efficient manner. Before this was invented, you had to do what y'all will be learning how to do, which is pacing, which is taking a step and estimating distance, whereas this thing is more accurate. So this is our grading tool for you guys when we go to do our compass and pacing. So anyway, so like we said, this is a measuring wheel. It's used to estimate distances between 2 points. It's also used to find boundary lines and all kind of other opportunities. These two pieces of equipment are used together. This is a land measurement compass, and if you look, it actually says land measure compass there. You notice the north, east, southwest. And this is considered either a engineer scale or a land measurement ruler, as we'll call it in this class. These two pieces of equipment are used to either A, draw a section of land to scale, or B, you can actually estimate the size of a piece of property on a map by using this scale stick. I doubt we get to this in basic ag, but if you take forestry, you get to learn more about drawing a scale and how those pieces are used in the forest industry.